Hello everyone, I'm George from University of Southern California, and today I'm presenting our work on Crosstown Foundry, a scalable data-driven journalist platform for hyperlocal news. This project is a collaboration between the Integrated Media Systems Center and the Annenberg School for Communication and Journalism at USC. This is the outline that I'm going to follow today. So first, let's introduce our problem. Like many other industries, journalism is impacted by the vast amount of data and information available. For example, nowadays we have traffic data available, crime data, health data, just to name a few. And news publishers develop in-house expertise to provide editors with data science skills so that they can analyze and visualize this data and create data-driven stories. However, scaling of this emerging journalistic model is challenging because now we are shifting from the printed material to the online news format, which has tighter integration of news into social media platforms. Local news outlets are facing several challenges. To stay competitive, they need to create hyperlocal news for readers in their communities with limited amount of budget and resources. Additionally, data shared in public are not directly consumable content for the everyday reader. For example, data are not in a standardized format, such as data within a particular neighborhood that might be interesting for people living in that neighborhood. In addition, existing tools such as Many Eyes or Data Commons, although they aggregate and collect public data, they do not target journalistic applications and they do not adapt to hyperlocal data. So let's motivate our work with a real case scenario. This is a Lake County, and it has 273 different neighborhoods. A local news agency to cover these communities, they have to hire more reporters and editors, which is cost prohibitive for small outlets. The smarter business decision has been to shrink rather than to expand. However, this creates news deserts, which are areas that receive little or no coverage at all. In addition, cities in Los Angeles County share public data repositories that are relevant. So this is not a data scarcity problem. The challenge is that the data resources are not in a format that can be used for regional analysis. With Crosstown Foundry, we target to fill these news desert gaps. We allow readers to subscribe to neighborhoods of preference and receive customized newsletters in a weekly basis. Now let's see how this works. What you're seeing on your screen is Crosstown Foundry architecture. Crosstown Foundry was developed in partnership by engineers and journalists for Crosstown, a nonprofit news organization based on the University of Southern California's Annenberg School for Communication and Journalism. It allows local news to do something that never before was possible: create numerous local reports at scale and generated automatically without any added costs. The figure on the right represents an overview of the Crosstown ecosystem. It follows a three-tier architecture with a presentation, access, and storage layer. The front layer includes the Foundry dashboards used to create the newsletters and other hyperlocal news content. The different products dashboards provide the data exploration to readers of the Crosstown website and newsletter subscribers. The API layer provides the access to the data and services for those dashboards and also for the Foundry to publish and distribute content. The storage layer is where the Crosstown databases store crime, health, transportation, and other data, and newsletter subscriber information. The different Foundry assets such as content templates, page templates, mixins, and published HTML content. Currently, there are four main categories of data. Those are crime, health, traffic, and other kinds of data that range between a few thousand to a few million records. To support hyperlocal reporting, we assign a neighborhood to each record and construct indexes so that we can speed up the API queries. This is a screenshot from the Crosstown Foundry web application. First, editors log into the system and create a new newsletter at a weekly basis. Because the information such as the population, the number of COVID cases, or the number of crimes, etc., is varied between neighborhoods, generating a newsletter customized for each of those neighborhoods is time consuming to do manually. Typically, a newsletter is generated dynamically from a content template in Markdown format, as shown on the screen. Data-driven content, such as descriptive statistics and graphs, are embedded in the content template using some inline code syntax and closed in backticks. We refer to this data-driven content as mixins. Mixins encode data or data visualizations queried from our Crosstown databases, which is localized to a specific neighborhood, both in spatial and temporal extents when they are rendered. At publishing time, the Foundry renders the mixin into HTML published content. For example, the daytime mixin current week resolves to a specific date. For example, March 2nd, 2021. And the mixin COVID infections change with two time ranges correspond to the percentage change between those two dates. Some other examples include graphs. For example, the COVID infections bar weekly between this time range will result into a bar chart. Mixin signatures are standardized to allow for temporal aggregation and filtering using the syntax name, aggregation, and filter, where name is the unique registered name. Aggregation is a string used to define how the data should be aggregated temporarily, for example, weekly, monthly, yearly, and so on. And filter is a specific time range that you can use to filter the results or a specific type of crime in case of crimes or any other kind of filters. Those mixins are implemented as JavaScript modules that are instantiated at publishing time to render the content. And data-driven mixins obtain data through the data API layer. To make sure that the editing of mixins is correct, we have implemented a linter that validates the mixins when the new change is made on the markdown. After building this kind of template, this page shows a resulting page, which can be sent either by email or shared online. And this is an example where it's built for University Park neighborhood. So let's see how this works in action. These are the different links that you can use to see our project.
What you're seeing on your screen is the newsletter subscription page where subscribers can go and enter their details so that they can start receiving hyperlocal newsletters. Our neighborhoods are within Los Angeles County, and we have 110 different neighborhoods. Once they click sign up, they will start receiving weekly newsletters. To enable such newsletters for hyperlocal news, we have created a system named Foundry, where editors can go and log in. And what you are seeing in your screen are different templates that are used to build and then send a customized version of that template to each neighborhood that we have in our database. So let's go and check one of those. Each template has a name and some description. And this is the actual content that makes a template. So there is actual text in this template, and then there are those annotated mixins. Mixins are modules that are rendered using JavaScript, and those are rendered at the build time. For example, we have this temporal module current week, which is replaced with the start of the week that we are sending the newsletter. Or for example, we have COVID infections, which is replaced by a number in a text format when we render this. In addition, all these numbers are replaced based on the neighborhoods that this newsletter is built for. Additionally, we have other mixins that I'm going to show in a while that they are rendered as images, and you can add charts or you can add images and other backgrounds. So here is a list of the current mixins that we offer. We have 68 different mixins, and they can vary on their type. For example, here this mixin outputs the number of infections between this time range. Another one is this trend, which is a line between this time range representing the number of COVID infections within this time period. Another example is the collisions, which is again some line, and in this case we aggregate it by month, or for example you can aggregate by year and so on. Once editors finish their editings on the template, they can go and build this template. And what build this does, it will render for each template the different mixins. So this is what you see under prints. So this represents the build that we just created. Once you open this build, you can see that there are different pages for each neighborhoods, and this basically represents the actual content of the newsletter that they will receive on their email. As you can see, the different headers were rendered here. The time was replaced with the date that we are sending the email. There are mixins that are rendered as text, and there are others that are rendered as graphs, and so on. And this is localized for each neighborhood. After we send this to subscribers, a reader will be replaced with their actual name that they used during subscription, and they will receive this in their inbox. So this is an example of what I just showed. Additionally, we have designed some products that we can link to those newsletters. For example, we have created an interactive COVID map, and this redirects to our products website where you can interact with the actual data. So here what you can see is a heat map of all the COVID cases within Los Angeles. And this is an effort where we aggregate data from the Los Angeles Health Department. We organize them by neighborhood, and then we visualize them building different dashboards. So people can go and check their own neighborhood and see how it changes over time. Similarly, we have built different dashboards for traffic data, air quality, crimes, etc. For example, in our crime map, we have a similar heat map, but this represents the crime rate within Los Angeles County. Finally, our data enable new opportunities for journalists to report on hyperlocal news. So we have a website where we post stories on different kinds of data within Los Angeles, for example, related to crimes, air quality, and traffic. And one such example is the detective. Detective is basically a bot that we have implemented, which implements an outlier detection process that checks for abnormalities in data. And when these abnormalities are detected, Then they are posted in a Slack channel that we have connected, and journalists can go and check what's the abnormal data that are detected, and then write stories about it. So this is one example of such story. And in Slack, this is how the report looks like. So basically, there are different categories. For example, neighborhoods. You can see that this neighborhood exceeded some deviation based on some threshold that we have on this particular date. Other examples of outliers is when crimes have an expected number of victims, and this reports the top 4, and so on. So those are some leads that journalists can follow and write stories about. Thank you for your attention.